Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve this interesting problem about probability distribution. For the first problem, suppose you play a game of rolling a regular die 5 times. Let x be the number of times that 1 or 2 appear. Find the expected value and the variance of x. Now this first problem is really easy if you have learned this particular probability distribution. What's interesting is this second problem. For the game defined in A, find the expected value and the variance of 2 to the power of x. Now some of you might wonder what does this even mean, so let me provide you some supporting explanation. Suppose that if you roll the die 5 times and 1 or 2 appear x times, you earn 2 to the power of x dollars as a prize. Then the expected value of 2 to the power of x means the expected value of the prize you can earn from this game. Alright, now with these settled, let's solve these problems. In order to solve the first problem, first we must identify the probability distribution. And this is a very famous probability distribution, the binomial distribution. We need two parameters n and p to uniquely define a binomial distribution. N is a number of trials, which in this case is 5 since we roll a die 5 times. P is a probability of success, that is, probability that the event of our interest occurs in a single trial. In this problem, P is the probability of getting 1 or 2 in a single roll, hence it is 2 over 6 or 1/3. Therefore, we can write x follows the binomial distribution 5, 1/3. And the thing is, the expected value and the variance of x in a binomial distribution are given by these super simple formulas. The expected value is given as np, and the variance is given as npq, where the probability of failure q is equal to 1 minus p. So straight from the formulas, we obtain expected value of x is 5 times 1/3, so 5/3, and the variance is 5 times 1/3 times 2/3, so it is 10 over 9. But how can we calculate the expected value and the variance of 2 to the power of x? Well, in this case, there are no directly applicable formulas. So we have to use the general method to calculate the expected value and the variance. The general method to find the expected value is as follows. Here, k indicates the values that our random variable x can have, in this case from 0 to n. Then we have to add up k times the probability of x having the value of k. The definition of the variance is the expected value of the square of the deviation of x from ex. Therefore, from the expected value formula, the k part is now changed to k minus ex squared. So now it's the summation of k minus ex squared times the probability p of x equals k. As for the expected value and the variance of 2 to the power of x, all we have to do is to replace this k with 2 to the power of k and expected value of x with expected value of 2 to the power of x. With these settled, now it's time to address this probability part. In binomial distribution, it is given as the probability of independent trials. Basically, it is the probability of having k successes and therefore n minus k fails when we do n independent trials, which is given as n choose k times p to the power of k times 1 minus p to the power of n minus k. Therefore, substituting with this expression for the probability, we have sigma 2 to the power of k times n choose k, p to the power of k, 1 minus p to the power of n minus k, And in the given binomial distribution, n equals 5 and p equals 1/3, and therefore we have sigma k from 0 to 5, 2 to the power of k times 5 choose k times 1/3 to the power of k, and 1 minus p is 2/3 to the power of 5 minus k. And here we can actually combine these two and write sigma 5 choose k times 2/3 to the power of k times 2/3 to the power of 5 minus k. And let's take a closer look on this expression. Doesn't this look familiar? Well, this is the form where binomial theorem can be directly applied. Therefore, by the binomial theorem, this summation is simply equal to 2/3 plus 2/3 raised to the 5th power. So it is 4/3 raised to the 5th power, which is 1024 divided by 243. This is approximately equal to 4.21, meaning that if we play the game under the condition that we receive 2 to the power of x dollars as a prize, then on average we are expected to receive $4.21. Now let's move on to the variance. And yes, I wrote first method here because I will show you the second method later on. But for now, let us focus on the expression we obtained previously. Using the obtained expected value and probability of independent trials, we have sigma 2 to the power of k minus 1024 divided by 243 squared times 5 choose k times 1/3 to the power of k times 2/3 to the power of 5 minus k. Here we have to expand this square part, and unfortunately the numbers become rather messy. Here I will write the expected value as 2 to the power of 10 divided by 3 to the power of 5 in order to keep things as simple as possible. And if we expand, we obtain first 4 to the power of k, then minus 2 to the power of 11 divided by 3 to the power of 5 times 2 to the power of k, then plus 2 to the power of 20 divided by 3 to the power of 10. So we can actually split this into 3 terms. For the first part, we obtain 4 to the power of k times 5 choose k times 1/3 to the power of k times 2/3 to the power of 5 minus k. And for the second part, we have constant 2 to the power of 11 divided by 3 to the power of 5 to the front, and the summation of 2 to the power of k times 5 choose k times 1/3 to the power of k times 2/3 to the power of 5 minus k. And for the third part, we have constant 2 to the power of 20 divided by 3 to the power of 10, then the summation of 5 choose k times 1/3 to the power of k times 2/3 to the power of 5 minus k. For the first part, we can combine this 4 to the power of k and 1/3 to the power of k and write 5 choose k times 4/3 to the power of k times 2/3 to the power of 5 minus k. And for the second part, we can combine this 2 to the power of k and 1/3 to the power of k and write 5 choose k times 2/3 to the power of k times 2/3 to the power of 5 minus k, and the third part remains the same. So applying the binomial theorem again, the first part is 4/3 plus 2/3 to the power of 5, and the second part is minus 2 to the power of 11 divided by 3 to the power of 5 times 2/3 plus 2/3 raised to the power of 5, and the third part is 2 to the power of 20 divided by 3 to the power of 10 times 1/3 plus 2/3 to the power of 5. So we have 2 to the power of 5 here, then minus 2 to the power of 11 divided by 3 to the power of 5 times 2 to the power of 10 divided by 3 to the power of 5 here, and since this part is just 1, we have 2 to the power of 20 divided by 3 to the power of 10. So we have 2 to the power of 5, and then we have the common part 2 to the power of 20 divided by 3 to the power of 10, which leaves 2 at the second part, then minus 1 at the third part. So we have 2 to the power of 5 minus 2 to the power of 20 divided by 3 to the power of 10. And I gotta admit, there's no way to easily compute this without computing large numbers such as 3 to the power of 10, which is 59,049 by the way. So I just used the calculator and obtained the result. 840,992 divided by 59,049, or approximately 14.24. But we're not done yet because I said that there exists another method to calculate the variance. I said that the definition of the variance is the expected value of the square of deviations. But if you have learned the basics of expected value and variance, you might have also learned that this expression can be manipulated into the expected value of x squared minus the square of the expected value ex. In other words, the variance is given as the mean of the square minus the square of the mean. And I am going to use this property to calculate the variance of 2 to the power of x. So the variance of 2 to the power of x must be equal to the expected value of the square of 2 to the power of x minus the square of the expected value of 2 to the power of x. Here, the first part is the expected value of 4 to the power of x, so we have this minus 2 to the power of x squared. Here, the expected value of 4 to the power of x can be calculated by sigma k from 0 to 5, 4 to the power of k times the probability 5 choose k times 1/3 to the power of k times 2/3 to the power of 5 minus k, and the expected value of 2 to the power of x is 1024 over 243. Here, combining these two, we can write the first part as sigma 5 choose k, 4/3 to the power of k, 2/3 to the power of 5 minus k, and the second part is equal to 2 to the power of 20 divided by 3 to the power of 10, as I already explained in the first method. So we can apply the binomial theorem on the first part, which gives 4/3 plus 2/3 to the power of 5. So this minus 2 to the power of 20 divided by 3 to the power of 10. So 2 to the power of 5 minus 2 to the power of 20 divided by 3 to the power of 10. So we arrive at the same answer. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.